All right, so let's dive into something pretty mind-blowing. AI that can actually run programs, not just chat or write poems, but take real action in the digital world. And that's what Microsoft's new LAM is all about. It stands for Large Action Model. It's really pushing way past what we thought AI could do. All those times you're online clicking through endless steps, and you just wish you could tell the computer what to do. Just imagine saying, "Hey, order that thing I put in my cart," and it just happens. Well, LAM's getting us closer to that reality. And here's the really interesting part. This isn't just some, far-off research project. They've already integrated it with Microsoft Office. And in their test with Word, LAM wasn't just successful at completing tasks. It was actually faster than the super smart GPT-4. We're talking a 71% success rate for LAM compared to 63% for GPT-4. And speed. LAM wrapped things up in just 30 seconds. So why is LAM so much faster? Well, traditional language models process and generate text, but LAM translates your requests into tangible actions. It's kind of like the difference between understanding a recipe and actually baking the cake.
Like, if you need to book a flight, LAM could navigate those airline websites and make the purchase for you. So this shift from text to action is a total game changer. Instead of just telling us information, AI can now do things for us in the digital world. Now, how did Microsoft actually build this thing? Well, creating LAM is much more complex than your average language model. Think of it like teaching LAM two completely different languages. The first one is called task plan data, and that's like the high-level overview of the steps in a task. Like open a Word doc or highlight this text. And then you have task action data. And that's where you get down to the nitty-gritty. That's the precise sequence of actions to actually do those tasks. It's like the difference between telling someone to bake a cake and giving them a super detailed recipe with all the measurements and oven temperatures and everything. So imagine you're teaching LAM to schedule a meeting. The task plan data would be like, open the calendar, select a date and time, and invite attendees. But the task action data, that's where it gets really complex. That's where you would have to specify things like
Clicking the new event button, typing in the specific meeting details, and selecting people from your contact list. So once LAM has all this data, it goes through some pretty rigorous training. It's like boot camp for AI. First, there's supervised fine-tuning, where researchers actually guide LAM through these tasks, and they correct any mistakes it makes along the way. And then there's reinforcement learning, where LAM learns through trial and error and gets rewarded for every successful action. And then finally, there's imitation learning, where LAM observes human experts performing tasks. So it's not just following instructions, it's actually picking up on all the nuances of how do you interact with technology. And after all that training, LAM gets tested in controlled environments and then finally released into the wild. It really is an amazing feat of engineering. But the big question is, what does all this actually mean for the future? I mean, LAM really is a huge leap forward, not just in AI, but also in how do we interact with technology. We're moving from text-based AI to action-driven AI agents, and that opens up so many possibilities.
We're not just talking about automating, those mundane tasks that we all hate. We're talking about AI that can really empower people. Just imagine a world where anyone, regardless of their, tech skills, can effortlessly navigate the digital world. That's the real potential of LAM. But, let's be realistic for a second. Right now, LAM is still in its early stages. It's definitely impressive, but it's not perfect. Remember that 71% success rate we talked about? Well, that means there's still some room for improvement, and there are definitely some challenges ahead. For one thing, LAM needs a ton of data to learn. We're talking like terabytes upon terabytes of information about how we use programs and navigate the digital world. And that data has to be high quality. I mean, if LAM is trained on bad data, it could make mistakes, or even worse, learn some harmful behaviors. It's kind of like teaching a child with inaccurate textbooks. They might end up learning the wrong things. Another challenge is security. If LAM can control our programs, it could also be vulnerable to hackers. Just imagine the chaos if someone hijacked LAM and used it for malicious purposes. That's kind of a sobering thought, isn't it?
So while the possibilities are definitely exciting, I think we need to proceed with a little bit of caution. We need to think about the ethical implications, develop some really robust security measures, and just make sure that AI is used for good and not for harm. But ultimately, I'm pretty optimistic. I think LAM represents a huge step forward in AI, and I'm really excited to see where it takes us. Maybe someday soon we'll all have personalized digital assistants that can effortlessly handle all those tedious tasks that just clutter up our lives. And maybe, just maybe, LAM will even help us unlock some new possibilities, things we haven't even dreamed of yet. It's kind of like having a super-powered intern who never sleeps and is always learning. The potential is truly mind-blowing. So what do you think? Is LAM the future of AI? Is it a force for good or a potential threat? Just some food for thought as we step into this new era of action-driven AI.
Thanks for joining me on this deep dive. And until next time, keep exploring.